Hello, and welcome to Eyes on Success, a weekly program covering a wide variety of topics of interest to people with vision loss. I'm Nancy Torpey.
And I'm Pete Torpey.
This is not restoration of biological vision. This is the beginnings of artificial vision. And at some point in the future, it could become routine clinical therapy. Right now, it's a frontier, and we're looking for people who can help us navigate that frontier of how such a system might work and how it could be useful for them to improve their quality of life.
And as we'll hear in just a few minutes, this research is aimed at directly stimulating the visual centers in the brain with some brain implants.
We'll speak with principal investigators Philip Troyk and Frank Lane about how the system works and their search for research volunteers. But first, for our tip of the week. This week's tip comes from Phil Troyk and Frank Lane.
A tip is live your life as though each day is the most precious one you have. And I think, Frank, you can comment upon the altruism and adventurism that you've heard from people that attract them to such a project.
We didn't really quite understand what to do with that when we first started hearing about, going on an adventure, participating in pioneering activities. But we eventually, discovered that this was a genuine motivation. And it's not uncommon for individuals who want to participate in pioneering types of research, just like this one. And so we talk about that with our, prospective participants. We talk to them about what their motivation is for wanting to participate in the study. And it's been quite illuminating.
So if any of those traits describe you, you might be interested in being a volunteer for this study.
You are listening to Eyes on Success. Success, 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 success.
Let's start by meeting Phil and Frank.
We have two guests with us today who are working on a very interesting project and looking for volunteers. But before we get into some of the details, maybe we can have you guys introduce yourselves. Do you want to start, Phil?
Sure. My name is Phil Troyk, and I'm a professor of biomedical engineering. And I'm the executive director of the Pritzker Institute of Biomedical Science and Engineering, both at the Illinois Institute of Technology.
And Frank?
Yes, my name is Frank Lane, and I'm an associate professor of psychology. I'm also the chair of the Department of Psychology at Illinois Institute of Technology.
And did you guys know each other before this project started, or was the project the cause for your meeting?
I think it actually was the project, but Frank, as I remember, I think we met because of a project maybe you were working on for technology for blind swimmers, as I remember.
Yes,
yeah,
that's what it was.
Yeah, but then we quickly started trading notes, and this particular project for having a brain-based artificial vision system, Frank got intrigued by it, as most people who hear about it. And it's been a labor of love ever since.
So both of you are sighted. Does either of you have a personal experience with blindness or vision loss?
Personally, I do not, but it's an area that I have worked in throughout my career. And so it's an area of genuine interest of mine.
So for me, no, I don't have anyone in my family, or I don't have any personal experience with people who have blindness. I got exposed to it when the National Institutes of Health was running this project, which we kind of inherited and adopted. And candidly, at first, it was kind of an engineering technical problem, but it's very easy to become seduced by it, and realizing that the possibility of using technology to have people regain some visual perception just kind of became a life's work.
Support for Eyes on Success is made possible in part by our corporate partners.
Find out more about partnership opportunities by sending an email to hosts at eyesonsuccess.net.
This week's focus topic is the Intracortical Visual Prosthesis project and their search for appropriate volunteers to participate in it.
In the introduction, you guys kind of tantalized our audience with the fact that in some sense you're trying to restore vision, or at least restore perception of vision to people. Can you give us a quick summary of what your project is?
There's multiple aspects to it, but I'd just like to say at the onset, it's not really about restoring biological vision. No one has the technology to do that. This isn't Star Trek. But it's really the possibility of creating artificial vision. And in our case, it's by taking images that would be captured by a camera and communicating them directly to the brain through a collection of implantable devices that's put into the occipital lobe, which is right in the back of the head, directly and in a wireless fashion. And so there's a technological aspect to it, but our project is somewhat unique in that it's very much user-centric. And Frank, maybe you'd like to comment about how in our particular project, the motivations and perspectives of the user are extremely important.
Yes, that's something that we have found in our research, is that individuals can be motivated to participate in a study like this for a variety of different reasons. But ideally, what we're doing is looking for individuals who are motivated primarily by altruism. And also, everyone who's blind has a wish to have some type of sight back that's usable sight for themselves. So both of those, as well as a desire to participate in pioneering research, because this is definitely pioneering and it's something that individuals are very attracted to who are attracted to pioneering kinds of activities.
We're going to spend most of this show talking about what the research is, what people can hope to get back in terms of any kind of visual experience. But you did mention that you're looking for volunteers, and we'll go over the contact information at the end as always. But can you just tell people up front how they would contact you if they do want to volunteer?
We can be contacted by email at icvp@iit.edu. Again, that's icvp@IIT for Illinois Institute Technology.edu. Or you can also call a designated phone line that we have for the project is area code 312-567-5304. Again, that's 312-567-5304. And there's a voicemail attached to that number. So if you leave a message, we'll be notified immediately that a voicemail has been received.
And as Nancy mentioned, we'll also have the contact information at the end of the show in case you missed it.
And what does ICVP stand for?
You know, I'm glad you asked that, because I was just thinking the listeners must be thinking, what the heck does that mean? So ICVP means Intracortical Visual Prosthesis. And basically that means that it's a system to inject vision information via tiny electrical stimulators that have electrodes that are called intracortical, which means they penetrate the brain to a very short distance, 1 to 2 millimeters, which is about 10 thicknesses of a piece of paper thick. And this little collection of modules and electrodes can be communicated with wirelessly with no wires that cross the scalp. And the idea is that you take an image from a camera and you translate it into a language that the brain can understand, which we're still trying to discover, and you put the image information directly into the brain. It's kind of science fiction-like, but that's why it's a pioneering project. We're trying to understand what the capabilities might be of this system.
With a cochlear implant, there's a piece that's inside the head and a piece that's quite visible outside the head. And then the sensor looks kind of like a hearing aid. What does this end up looking like?
It's very much similar. The cochlear implant has an implantable part that's inside the head. And then outside, there is what's called a small transmitter coil. And that's about a couple of inches in diameter. In our case, because we're putting implants, small devices that are about the size of a pencil eraser or about the size of the button that's on a AA battery. Each one of those little stimulators has 16 electrodes, and we put a collection of them in there like a little cell phone network. And what goes on the outside of the head is a activator coil that's about 4 inches in diameter that is placed over the back of the head where the vision area is, and that wirelessly communicates with the implanted devices.
And then the sensor is some sort of digital video camera.
Right. It's built into glasses. Right.
So that's just on the frame of a pair of eyeglasses.
That's correct.
One thing that intrigues me here is that you said this is really placed on the surface of the brain. Is that where the visual part of the brain is, or is this just a convenient place to put it without risk?
Well, actually, the modules look like a little miniature hairbrush, if you could look under a microscope. And the electrodes are so small that the tips of them, you could put at least 10 of them on the tip of a human hair. So they're very, very tiny. If you think of like a little miniature hairbrush with 16 little electrodes sticking out about the thickness of 10 pieces of paper, these little modules are put in using a special insert tool during surgery. And the modules sit on the surface of the brain, but the little electrodes penetrate into the brain to the neurons that normally receive the signals from the optic nerves that project into there. So it's quite futuristic, but it's quite technically feasible.
And how do you know what pattern of signals to send to this part of the brain?
We don't. And that's why we need the volunteers.
I assume you've done some pre-studies where you know that if you stimulate that part of the brain, that the individual gets a sense of light versus darkness?
Yes, there have been many pre-studies in humans and in animals. And it's pretty well accepted that if you stimulate in this way, this region of the brain, that you will get visual perceptions, which sometimes are kind of spots of light or maybe regions of the perception of light that's about the size of a nickel at your arm's length. And these are called phosphenes. And the idea is that with a collection of these phosphenes, that you could use them maybe kind of like a light bright toy or an old scoreboard at a ballpark, and you could combine them together in a way that you could create the perception of vision.
You know, it's interesting. You talk about only having 16 electrodes on each of these devices, although I understand you can implant multiple devices. And that doesn't sound like a lot, but I'm totally blind these days, although I had partial vision. And once when I had my cornea removed, it was all fogged up, and just improving your vision a little bit. I couldn't see details, but it was enough to help me navigate and function in different ways by just learning what those stimulations meant. So I assume this is kind of similar.
So you had just mentioned about just a little bit of sight and what you were able to do with that. I interviewed a gentleman who was able to see 7 phosphenes, and with those phosphenes, they would form a line along the sidewalk so that he could ambulate more independently and safely. And he used this as a navigation system to walk from his house to their township where he would go every day. And he would also navigate his way to empty the trash at the end of his driveway. And the one thing that he talked about that really, when he did, he would smile as if it was really enhancing his quality of life, is he said that he could tell if he was seeing an oak tree because he would see the most number of phosphines and they would be the most brilliant lights. And it would light up like a Christmas tree for him.
Oh, interesting.
And I got to say, nobody understands that.
Right. But you do learn to interpret these subtle signs if you're open to it and you work with it somehow.
Yeah, I think that's really the hope that keeps us going as researchers, is that, almost half of the human brain is dedicated in some way to processing vision. And you got a lot of neural machinery there. And so the idea is that if we can find the right cues to communicate to the brain will start to figure it out. And it may be that the individuals, they won't have biological vision. That we know. I mean, you have 10 million connections that come to each side of your brain, and at the most, we could have 1,000 electrodes. But you got a lot of sophisticated neural machinery in your brain, and so if your brain can start to use this information, you might learn to see in a new way.
I assume that's where the psychology part of this team comes in. I mean, you don't have a psychologist on the team just to say, well, are people happy? What's your part of this project, Frank?
Well, at the outset of the project, we started by conducting educational sessions at the Chicago Lighthouse for the Blind, and that was to educate the blind community about the project, not recruit. And that was really the precursor to us beginning the recruitment piece, which is what's going on right now. And that's another area, is psychology screening, both at the pre-screening and at the screening level. So there's different levels of screening, and there's a psychology evaluation at both levels.
So you make sure that the test subjects are psychologically suitable for the study?
Yeah, so what we look for is how well someone is adjusted to being blind, if they've participated in vision rehabilitation at all, whether they have a good support system, that they've had vision loss for at least 1 year, that they have a realistic expectation for what the device will do. So these are just some examples of the kinds of things that we assess for. We also identified through our educational sessions that the information is highly complex and needs to be presented sometimes multiple times in order for someone to understand it. And we have very elaborate informed consent documents that we assessed through our psychological evaluation that someone has the capacity to understand all the complex information and make informed decisions for themselves. So there's a lot of different areas that the psychology component has been involved in, and we plan to continue to stay involved even after implantation to evaluate the participant ongoing, as well as impact on quality of life, things like that.
Do you get involved in psychophysical evaluations?
That's another major part of it. And we have a whole other portion of our team that's dedicated to that, to test and to really get the feedback from the implanted person on what they're perceiving, because it is a frontier. And we really think of the 5 volunteers that we're recruiting as going to a place that people haven't been before. We equate it to the astronauts who were recruited to fly into outer space for the first time, and they had to tell us what they were seeing.
Besides some of the psychological aspects, what else are you looking for in volunteers?
Well, the study is FDA approved. It's funded by the National Institutes of Health. And the requirements are that any volunteer have no light perception or only bare light perception in both eyes. And so if a person can see a hand waving in front of their face, they have too much vision. And that's simply because we don't know exactly what's going to happen. And we wouldn't want to risk a person losing whatever minimal vision they may already have.
How many trips to Chicago does this involve?
Well, it depends upon the particular person and how they can navigate it. Ideally, we'd like people who live in the Northern Illinois area, but we expanded our recruiting nationwide and even worldwide. And so after implantation, which will be done at Rush University Medical Center.
And that's in Chicago.
That's in Chicago. The person would have to be available to come about a couple times a week to our testing lab, which will be at the Chicago Lighthouse for people who are blind and visually impaired, for about a 3 to 6 month period. And then there would be some follow-up after that. But we're very flexible in figuring out what the logistics will be.
How long does the participant keep the implant in? Just during the study, or does it stay forever?
Yeah, so the implants are very tiny. And as far as we know, and the FDA agrees, there is no significant risk to implantation. And to explant them would only be done in a case of medical need.
Explant means take it out.
Means take it out, yes. So the devices are very tiny. They're put in, the skull's closed up and the scalp's closed up. And so unless there was a strong medical need to remove them, the recommendation would be to just leave the devices. Surgeons put in devices that are a lot bigger than this in people's heads all the time.
I guess that's pretty common these days. I mean, they do things like that for Parkinson's, and they're doing studies with people with motor control from the brain and things like that. This is getting more and more common.
Yeah, our system is unique in that a lot of what are called brain-machine interfaces have electrode arrays, and then there's a connector on the side of the head where you actually electrically connect. In our case, everything's fully implanted. It's like a little miniature cell phone network in your head. And you could have up to 40 of these devices implanted, and we can call each one up and tell it what to do and tell it how to communicate with the brain.
And they're powered from the outside.
They're powered through this coil that's placed on the head, which can be in a hat, or it can be, one person even asked, could it be in a toupee? And we said, yeah, we think it probably could. But it magnetically powers it, kind of like, you know, you have your near field magnetic charging of your phones now, where you just put it on a pad. It's kind of like that, except on a slightly larger scale.
Well, that's great. So the risk really is kind of minimal of getting infections through wires that might be going through your skull and stuff.
There's no wires that exit out of the brain. There's no wires. That's kind of a unique feature of the system, because that allows it to be chronically implanted, which means we can really exploit how the person can learn, because there's no sense of urgency. It doesn't have to be removed.
When do you expect to start getting results? I mean, you talked about doing the implantation and seeing people a couple times a week for 3 to 6 months.
Well, after we implant the first individual, there will be there's a 1 month recovery period, but within 2 to 3 months, we'll have results and we'll know from the first person. Of course, you can't necessarily tell anything from one person.
Yeah,
that's why the study funded by the NIH wanted us to have 5 volunteers, because that at least gives you, some kind of average across individuals. But we're very hopeful and we're very enthused. We've been working on this project for over 20 years. And so, frankly, all of us are very anxious to see what the first and subsequent individuals will tell us in the first couple months after they begin testing.
You are listening to Eyes on Success. Success, 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 success.
Now for this week's final item, how to learn more about the Intracortical Visual Prosthesis Project, or ICVP, how to become a participant, and how to contact Phil Troyk, Frank Lane, or the rest of the team.
Well, if some of our listeners are interested in learning more and perhaps participating in this research project, how would they go about it, and what are the requirements again?
They would go about it first by contacting us. And there's a few ways that they can do that. First is to call us at area code 312-567-5304. That's 312-567-5304. There's a voicemail attached to that number, and if you leave a message, it will notify us immediately and we'll be able to contact you. The email address for the project is ICVP for Intracortical Visual Prosthesis at IIT.edu. Again, that's ICVP at IIT.edu. You can also go to the main project page at the chicagolighthouse.org/ICVP.
And I guess on that webpage, it describes the project in a little bit more detail, along with some of that contact information, so people can learn more?
Yes, we have not only information there, but we have extended information sessions that were recorded previously, so you can listen to much more extensive information. And there's a lot of information on the Chicago Lighthouse site. We're very lucky to have them as partners.
And if people had questions for either of you, is it possible to contact you directly?
The best way to do it is through the contact information Frank just gave, because we get back right away. And there's a multi-phased process for screening people. So, first there's kind of an informal discussion, and there's a pre-screen, and then there's a screening process. So there's really no commitment to just inquire.
And this project is starting soon or now?
This project has started. We are recruiting right now.
When do you expect to start implanting devices?
We will start implanting as soon as the first individual qualifies.
Great. And hopefully we can contact you after some of that research is underway, and you can give us some feedback on that.
We'd love to do so.
And as usual, you can find all of that contact information in the show notes associated with this episode at www.eyesonsuccess.net.
That's it for show number 2151. Next week on Eyes on Success, we'll be talking about the Apple HomeKit and the smart home. There are a myriad of devices based on the Apple HomeKit, but how are they used, and which ones have the functionality you might be looking for, and which ones are accessible to people with vision loss? We'll speak with Dustin Bogus, who is visually impaired himself, about his My HomeKit home videos, blog, and website that aim to show users what can be expected from such devices and how they work.
So join us next week if you want to hear more about making your home a smart home.
You've been listening to Eyes on Success, hosted and produced by Nancy Torpey and Peter Torpey.
You can access the full archive of previous shows, subscribe to the podcast, and much more by going to our website, www.eyesonsuccess.net. If you have questions about anything you've heard on the show or have suggestions for future shows, send an email to hosts@eyesonsuccess.net.
Thank you for listening, and have a nice day.